In 1958, in an unremarkable building in the American Midwest, a small group of scientists was working in secret on a plan that, if carried out, would have changed the face of the moon forever. Not figuratively, literally. The plan was to detonate a nuclear weapon on the surface of the moon, to set off an atomic explosion so that the flash could be seen from the Earth with the naked eye, a demonstration of American power written across the night sky for the entire world to witness. The project had a code name, and it was classified at the highest level. Among the scientists working on it was a young researcher who would one day become the most famous science communicator in the world, a man named Carl Sagan. The plan was real. It was studied seriously, and it came closer to happening than almost anyone today would believe. This is the story of the most audacious and frightening idea of the space race, the secret American plan to drop a nuclear bomb on the moon, why two superpowers each considered doing it, and why, in the end, the wisest thing either of them did was to choose not to. The year was 1958. The place was the Armor Research Foundation, a scientific institution in Chicago, Illinois, that conducted research under contract for the United States government and military. In an office there, a physicist named Leonard Reiffel received a request that would have seemed, to anyone outside the small circle of those cleared to know, like something out of science fiction. The United States Air Force wanted to know whether it was possible to detonate a nuclear weapon on the moon, and whether the resulting explosion would be visible from the Earth. Reiffel was no stranger to serious scientific work. He was an accomplished physicist who would go on to a distinguished career, including senior positions at NASA. But the request that came across his desk in 1958 was unlike anything he had been asked before. The Air Force was not speaking in hypotheticals or idle speculation. It wanted a genuine feasibility study, a rigorous scientific assessment of whether a nuclear device could be delivered to the moon, detonated on its surface, and seen from the Earth, and what the scientific and military implications of such an act would be. The project was given an official name, deliberately bland to conceal its true nature. It was called A Study of Lunar Research Flights. Within the small group who knew of it, it carried the designation Project A119. Reiffel assembled a team to conduct the study, and the team he gathered included some of the brightest young scientific minds available. Among them was a graduate student in his early 20s, a young astronomer of obvious brilliance who was beginning to make a name for himself, named Carl Sagan. Decades later, Sagan would become a household name, the author of best-selling books, the host of a landmark television series about the cosmos, the most eloquent and beloved popularizer of science in the world. But in 1958, he was a young researcher, and one of his early assignments was to work on the question of what would happen if the United States exploded a nuclear bomb on the moon. What the men gathered around that table in Chicago did not fully appreciate as they began their classified study in 1958 was that they were not merely conducting an academic exercise. They were studying a plan that the United States government was seriously considering carrying out, a plan born of a moment of national panic and desperation, a plan that would have detonated a nuclear weapon on the surface of another world and announced American power to the entire planet in a flash of atomic light. The study they were about to conduct would be thorough, rigorous, and entirely real. And the question of whether the United States would actually go through with it, whether the moon would be marked forever by an American nuclear explosion, would hang in the balance for the better part of 2 years. To understand how the United States came to seriously consider detonating a nuclear weapon on the moon, it is necessary to understand the state of mind that gripped the nation in the months after October 1957. On the 4th of that month, the Soviet Union had launched Sputnik, the first artificial satellite, and the event had struck the United States with a force that is difficult to overstate. The shock was not merely that the Soviet Union had reached space first. It was that the achievement overturned the deepest assumption Americans held about their place in the world, the assumption of unquestioned technological supremacy. For a nation that had built the atomic bomb and emerged from the Second World War as the dominant power on Earth, the sight of a Soviet machine passing overhead, beeping down at American cities, was a profound and frightening humiliation. The humiliation deepened in the months that followed. The Soviet Union launched a second satellite, carrying a dog, demonstrating that its first success had been no fluke. And when the United States attempted its own answer in December 1957, the Vanguard rocket rose a few feet off the launch pad and exploded on live television, an embarrassment that the world's newspapers mocked mercilessly. The combination of Soviet success and American failure produced a crisis of national confidence. Americans asked how their nation had fallen behind, whether their schools were failing, whether their system had grown complacent, while the Soviet Union surged ahead. The fear was real and pervasive, and it created enormous pressure on the American government to do something, anything, to demonstrate that the United States remained a great power, capable of matching and surpassing the Soviet Union. It was this pressure, this desperate need for a gesture that would restore American prestige and shake the confidence of the Soviet Union, that gave rise to the idea of a lunar nuclear explosion. The logic, in the panicked atmosphere of 1958, had a certain terrible appeal. The Soviet Union had impressed the world by placing a small satellite in orbit. What if the United States could do something far more dramatic, far more visible, far more impossible to ignore? What if the United States could detonate a nuclear weapon on the moon, producing a flash of light that would be visible to people around the world? A demonstration that America possessed both the rocketry to reach the moon and the nuclear power to mark it. Such a display, the thinking went, would erase the humiliation of Sputnik in an instant, would demonstrate American technological and military superiority in the most unmistakable terms, and would intimidate the Soviet Union by showing what the United States was capable of. The idea was, by any sober assessment, extraordinary, and it reflected the degree to which the post-Sputnik panic had unsettled normal judgment. In ordinary times, the notion of detonating a nuclear weapon on the moon would have been dismissed out of hand. But these were not ordinary times. The nation was frightened, its confidence shaken, its leaders under intense pressure to respond to the Soviet challenge. In that atmosphere, ideas that would normally have been unthinkable received serious consideration. The proposal to study a lunar nuclear explosion was not the product of madness or whimsy. It was the product of a specific historical moment, a moment of fear and wounded pride, in which the United States was casting about for any means to reassert itself against a rival that had, for the moment, seized the initiative in the most visible arena of the Cold War. The military rationale extended beyond mere display. A successful lunar nuclear detonation would demonstrate that the United States possessed the capability to deliver a nuclear weapon across the vast distance to the moon, which implied the capability to deliver one anywhere on Earth. It would be, in effect, a demonstration of intercontinental and beyond intercontinental strike capability, a message to the Soviet Union that American nuclear weapons could reach any target. The scientific community would also gain data about the moon and about nuclear detonations in the space environment. The combination of psychological, military, and scientific objectives gave the proposal enough substance to justify a serious study, and so the study was commissioned, the team was assembled, and the United States began, in secret, to investigate whether it should mark the moon with the light of an atomic bomb. The transformation of a panicked notion into a formal classified study followed the path that significant military projects typically take, moving from an idea raised in discussion to a funded program with a designated team and defined objectives. The United States Air Force, which had institutional responsibility for much of the American missile and space effort in this period, took the lead in pursuing the concept. The Air Force was engaged in an intense rivalry with the other military branches over control of the emerging space mission, and a dramatic demonstration of lunar capability would have served the Air Force's institutional interests as well as the nation's strategic ones. The proposal to study a lunar nuclear detonation was formalized, funding was arranged, and the work was contracted to the Armor Research Foundation, where Leonard Reiffel and his team would conduct it. The objectives of the study were defined across several dimensions, each of which reflected a different motivation for the project. The first and most prominent objective was psychological. The explosion was intended, above all, to be seen. The entire point was that people around the world would look up at the moon and witness with their own eyes a flash of light produced by an American weapon. The visibility was the purpose. A nuclear detonation conducted in secret, or one that could not be seen from the Earth, would have served no propaganda function. The planners, therefore, had to ensure that the explosion would produce a flash bright enough and well placed enough to be observed from the Earth by ordinary people, a requirement that would shape many of the technical decisions about how and where the detonation should occur. The second objective was military and strategic. A successful lunar detonation would demonstrate American capabilities in the most unambiguous terms. It would show that the United States could deliver a nuclear weapon across the 250,000 miles to the moon, an achievement that implied the ability to deliver nuclear weapons to any point on the Earth with precision. In the context of the missile gap fears that gripped the United States in this period, when Americans worried that the Soviet Union held a decisive advantage in intercontinental missiles, a demonstration of the ability to hit the moon would have been a powerful statement of American strategic reach. It would have told the Soviet Union and the world that American nuclear weapons could go anywhere, that no distance was beyond their reach. The third objective was scientific. A nuclear detonation on the moon would, the planners reasoned, produce valuable data. It would provide information about the nature of the lunar surface, about how the moon's soil and rock would respond to a nuclear blast, about the behavior of an explosion in the vacuum and low gravity of the lunar environment. Scientists studying the moon, which remained in 1958 a largely mysterious body about which much was unknown, might learn a great deal from observing how it responded to a nuclear detonation. This scientific rationale provided a measure of intellectual respectability to the project, allowing it to be framed not merely as a propaganda stunt, but as a genuine scientific investigation that would advance human knowledge of the moon. These three objectives, the psychological, the military, and the scientific, combined to give the project enough justification to proceed to serious study. But the central purpose, the one that had given rise to the idea in the first place, and that overrode the others in importance, was the psychological one. The United States wanted to do something dramatic enough to erase the humiliation of Sputnik and to reassert American supremacy in the eyes of the world. The scientific data would be welcome, the military demonstration valuable, but the fundamental driver was the desire for a spectacular, visible, world-altering demonstration of American power. The moon was chosen as the stage for this demonstration, precisely because it was visible to everyone, the one object in the sky that every human being could see, the perfect canvas on which to write a message of American strength. The choice of a nuclear weapon, rather than some other kind of demonstration, reflected both the technology available and the desire for maximum impact. A conventional explosion on the moon would have been far too small to be seen from the Earth. Only a nuclear detonation could produce a flash bright enough to be visible across the 250,000 miles separating the Earth and the moon. The nuclear weapon was not incidental to the plan. It was essential to it, because only the immense energy of a nuclear explosion could produce the visible effect that the entire project was designed to achieve. The planners were not proposing to use a nuclear weapon because they wished to use one for its own sake. They were proposing it because the goal of a visible lunar explosion could be achieved by no other means. As the study took shape through 1958, it acquired the characteristics of a serious scientific and engineering investigation. The team had to address a host of difficult technical questions. What size of nuclear device would be required? How would it be delivered to the moon, given the limited rocketry available? Where on the lunar surface should it be detonated to maximize visibility from the Earth? What would the explosion actually look like from the Earth? And how could the planners be sure it would be visible? Each of these questions required real analysis, and the team set about answering them with the rigor that the Air Force expected. Among the questions assigned to the young Carl Sagan was one of the most scientifically interesting: the question of how the cloud of dust and debris thrown up by the explosion would behave in the vacuum of space, and whether that cloud would help or hinder the visibility of the detonation from the Earth. The folly of the project's conception did not prevent the seriousness of its study, and for the better part of 2 years, some of America's brightest scientific minds applied themselves to the question of how to drop a nuclear bomb on the moon. The team that Leonard Reiffel assembled to study the lunar nuclear detonation was a group of capable scientists drawn together to address a problem that combined physics, astronomy, and the grim mathematics of nuclear weapons. The work required expertise in several fields. Someone had to understand the physics of nuclear detonations and how a weapon would behave in the vacuum and low gravity of the lunar environment, conditions utterly different from the terrestrial atmosphere in which all previous nuclear tests had been conducted. Someone had to understand the optics of the problem, the question of how bright the explosion would be, and whether it could be seen across the vast distance to the Earth. And someone had to understand the moon itself, its surface, its environment, and how it would respond to and display such an event. Reiffel gathered the talent he needed, and among the young researchers he brought into the project was Carl Sagan. Sagan, in 1958, was in his early 20s, a graduate student of extraordinary promise, who had not yet achieved the fame that would later make him one of the most recognized scientists in the world. He was studying astronomy and astrophysics, and he possessed precisely the combination of scientific rigor and imaginative reach that the project required. His assignment within the study concerned one of the most scientifically intriguing aspects of the proposed detonation: the behavior of the cloud of dust and gas that the explosion would throw up from the lunar surface, and the implications of that cloud for the visibility of the explosion from the Earth. The question Sagan was asked to address was genuinely difficult and genuinely interesting. When a nuclear weapon detonated on the surface of the moon, it would vaporize and eject an enormous quantity of lunar material, throwing dust and debris outward from the point of detonation. On the Earth, such a cloud would be shaped by the atmosphere and by gravity in familiar ways. On the moon, with no atmosphere and only a sixth of the Earth's gravity, the cloud would behave entirely differently. The dust would expand into the vacuum unimpeded, spreading outward in ways that depended on the physics of the explosion and the lunar environment. Sagan's task was to model this expansion, to understand how the cloud would develop, and to determine whether it would enhance the visibility of the explosion by catching and scattering sunlight, or whether it would do little to aid visibility. The brightness of the flash, and thus the success of the entire propaganda objective, depended in part on understanding this cloud. There was a deeper scientific dimension to Sagan's work that reflected the genuine intellectual content beneath the project's alarming purpose. The behavior of material ejected from the lunar surface bore on real scientific questions about the moon, including questions about whether the moon might harbor any traces of organic molecules or other materials of scientific interest. Sagan, whose later career would be devoted in significant part to the search for life beyond the Earth and to the study of planetary atmospheres and surfaces, was even at this early stage thinking about the moon as an object of genuine scientific inquiry. The detonation, whatever its propaganda purpose, would constitute a kind of experiment, and Sagan approached his portion of the study with the scientific seriousness that would characterize his entire career. A remarkable detail emerged decades later concerning Sagan's involvement, a detail that illustrates both the secrecy surrounding the project and the way that secrets can leak through unexpected channels. In 1959, Sagan applied for a prestigious academic fellowship, and in the application, he apparently referred to his classified work on the lunar project, disclosing information that was supposed to remain secret. The disclosure was a potential violation of national security protocols, an inadvertent revelation of a classified program in a document that was not itself classified. The matter was not noticed at the time, and it came to light only many years later, when a biographer researching Sagan's life examined his early records and found the reference. By then, the project itself had long since been declassified, and the disclosure was a historical curiosity rather than a live security concern. But it stands as a small illustration of how thoroughly the young Sagan had been involved in the project, that he considered the work significant enough to mention in a fellowship application, and of how the secrets of the Cold War could escape through the ordinary documents of a scientist's career. The contrast embodied in Sagan's involvement is one of the most striking aspects of the entire story. Carl Sagan would become, in the decades that followed, the world's most eloquent advocate for the peaceful exploration of space, for the wonder and beauty of the cosmos, for the preciousness of the Earth as seen from the perspective of the heavens. His later work celebrated the moon and the planets as objects of beauty and scientific fascination, to be explored and understood, not marked by the weapons of human conflict. He would become a prominent voice against nuclear weapons, warning of the catastrophe of nuclear war and the concept of nuclear winter. And yet, at the start of his career, this same man had worked on a project to detonate a nuclear weapon on the moon. The contrast is not a contradiction so much as a measure of how the panic of the early Cold War swept up even the most brilliant and humane of minds, drawing them into the service of ideas that, in calmer times and with greater maturity, they would have found abhorrent. The young Sagan studied how to bomb the moon. The mature Sagan taught the world to love it. Between those two Sagans lay the distance that the United States itself would travel, from the panic that conceived the bombing to the wisdom that rejected it. The technical challenge of actually detonating a nuclear weapon on the moon was formidable, and the study had to confront a series of difficult problems, each of which pushed against the limits of what 1958 technology could accomplish. The first and most basic problem was delivery. To detonate a weapon on the moon, the United States first had to get a weapon to the moon, and in 1958, the rocketry required to do so barely existed. The missiles available at the time were intercontinental ballistic missiles designed to deliver warheads to targets on the Earth, not to escape the Earth's gravity entirely and travel to the moon. Reaching the moon required achieving escape velocity and navigating across 250,000 miles of space to arrive at a specific point on the lunar surface, a feat that the United States had not yet accomplished with any payload, let alone a nuclear weapon. The delivery problem shaped the choice of weapon, because the limited lifting capacity of the available rockets constrained how much mass could be sent to the moon. A large, heavy nuclear device would require a more powerful rocket than was available. The planners therefore had to consider smaller, lighter weapons that could be delivered with the rocketry that existed or that would soon exist. The study considered the use of a relatively small nuclear warhead, lighter than the massive thermonuclear weapons of the era, a device that could be accommodated within the payload limits of the missiles available. The choice reflected a compromise between the desire for a large, bright explosion and the practical necessity of delivering the weapon with the rockets at hand. The weapon had to be powerful enough to produce a visible flash, but light enough to be sent to the moon. The second major problem was the placement of the detonation, and this is where the science became genuinely subtle. The entire purpose of the explosion was that it be seen from the Earth, and the visibility of the flash depended heavily on where on the lunar surface it occurred. If the detonation took place on the sunlit portion of the moon, the flash might be lost against the brightness of the illuminated surface, difficult to distinguish from the moon's normal reflected light. If it occurred on the dark portion of the moon, the part not illuminated by the sun, the flash would stand out dramatically against the darkness, a sudden point of light where there had been none. The planners concluded that the detonation should occur near the terminator, the line dividing the lit and unlit portions of the moon, where the explosion would be set against darkness and would be most visible from the Earth. The choice of the terminator as the detonation point was a piece of genuine optical reasoning, an application of real science to the macabre purpose of maximizing the visibility of a nuclear explosion on another world. The third problem concerned the appearance of the explosion itself, and this was the question to which Sagan's work on the dust cloud was directed. A nuclear detonation on the Earth produces its characteristic fireball and mushroom cloud because of the interaction of the explosion with the atmosphere. On the Moon, with no atmosphere, the explosion would behave entirely differently. There would be no fireball of the familiar kind, no mushroom cloud shaped by atmospheric forces. Instead, the explosion would produce a brief, intense flash of light, and it would eject a cloud of vaporized and pulverized lunar material that would expand into the vacuum. The visibility of the event from the Earth depended on the brightness of the initial flash, and on whether the expanding cloud of debris would catch sunlight and remain visible, or whether it would disperse too quickly and too thinly to be seen. The planners needed to know what an observer on the Earth would actually see, and answering that question required the kind of modeling that Sagan and his colleagues undertook. The calculations involved real uncertainty, because no one had ever detonated a nuclear weapon on the Moon or anywhere in the space environment, and the behavior of such an explosion had to be predicted from theory rather than observed from experience. The planners could draw on the extensive data from terrestrial nuclear tests, but they had to extrapolate that data to the radically different conditions of the lunar surface, with its vacuum, its low gravity, and its airless sky. The predictions were necessarily approximate, and there was genuine uncertainty about exactly how bright the explosion would be and how clearly it would be seen from the Earth. This uncertainty was itself a problem for the project, because the entire propaganda value depended on the explosion being clearly visible, and if the planners could not be confident that it would be visible, the rationale for the whole undertaking weakened. The study, then, was a serious piece of scientific and engineering work, applied to an extraordinary purpose. The team addressed the delivery problem, the placement problem, and the visibility problem with rigor, producing analyses and recommendations that treated the lunar nuclear detonation as a genuine engineering proposal rather than a fantasy. The work demonstrated that the project was, at least in principle, technically feasible, that a nuclear weapon could plausibly be delivered to the Moon and detonated there, and that the resulting flash could plausibly be made visible from the Earth, particularly if it occurred near the terminator. The conclusion that the project was feasible was, in a sense, the most alarming result of the study, because it meant that the only barriers to actually carrying it out were matters of policy and judgment rather than technical impossibility. The science said it could be done. The remaining question was whether it should be done, and that question, as the study proceeded and as the implications became clearer, increasingly answered itself. The work that Carl Sagan contributed to the lunar study went beyond the immediate question of how visible the explosion would be, and it reflected the scientific instincts that would define his entire career. Sagan was not content to treat the Moon merely as a target, a surface against which to demonstrate American power. He approached it as a scientist approaches any natural object, with curiosity about what it actually was and what could be learned from it. Even as he calculated the behavior of the dust cloud that the detonation would produce, he was thinking about the deeper scientific questions that such an event might illuminate, and about the scientific costs that it might impose. One of the genuine scientific questions that interested Sagan concerned the possibility that the Moon might harbor traces of organic molecules or other materials of scientific significance. In 1958, the composition of the lunar surface was poorly understood. The Moon had never been visited, never sampled, barely studied at close range. Scientists did not know with certainty what its surface was made of, whether it held any water, whether it might contain any organic compounds, whether its soil preserved any record of the early history of the solar system. These were open questions of real scientific importance, and the moon was a natural laboratory for investigating them, a body that had remained largely unchanged for billions of years, preserving a record that had been erased on the geologically active Earth. Sagan understood that the moon was scientifically valuable precisely because it was pristine, and he understood that a nuclear detonation would compromise that pristine condition. This understanding pointed toward one of the deepest objections to the entire project, an objection that was scientific rather than military or political. To detonate a nuclear weapon on the moon would be to contaminate it, to scatter radioactive material across a surface that had been undisturbed for eons, and to compromise forever the scientific value of the lunar environment. Future scientists who wished to study the moon in its natural state, to sample its undisturbed soil, to search for organic molecules or traces of the solar system's early history, would find their work complicated or ruined by the radioactive contamination that a nuclear detonation would leave behind. The explosion would, in a sense, vandalize a natural treasure, marking the moon with human radioactivity for the sake of a propaganda gesture. Sagan, with his scientific reverence for the moon as an object of study, would have been acutely aware of this cost. The dust cloud calculations themselves connected to these scientific concerns. The cloud of material ejected by the explosion would not simply provide a visible flash. It would also represent lunar material thrown up from the surface, material that scientists might wish to study, scattered and altered by the blast. And the radioactive products of the detonation would mix with this material and settle back onto the lunar surface, spreading contamination across an area far larger than the immediate site of the explosion. Sagan's modeling of how the cloud would expand and settle was therefore not merely about visibility. It was also, implicitly, about how widely the contamination would spread, about how much of the moon would be affected by the radioactive debris of a single detonation. The science of the dust cloud was the science of both the propaganda flash and the lasting damage. As the study proceeded, the accumulation of such considerations began to shift the assessment of the project. The technical feasibility was established. A weapon could be delivered, detonated, and seen. But the closer the scientists looked at the actual consequences, the more troubling the project appeared. The scientific damage to the moon was one consideration. The risk of failure was another, and it was a grave one. The rocketry of 1958 was unreliable, prone to failure, as the repeated explosions of American test rockets had demonstrated. If a rocket carrying a nuclear weapon toward the moon failed during launch or early flight, the weapon might fall back to the Earth, potentially detonating or scattering radioactive material over populated areas. The prospect of a nuclear weapon falling back onto American or Allied territory because of a rocket failure was a nightmare scenario, and the unreliability of the available rockets made it a real possibility rather than a remote one. There was also the question of how the world would actually react to a lunar nuclear explosion, and whether the reaction would serve American interests as the planners hoped. The project was conceived as a demonstration of American power that would impress the world and intimidate the Soviet Union. But it was at least possible that the world would react with horror rather than admiration, that the sight of the United States detonating a nuclear weapon on the moon would be seen not as a triumph, but as an act of reckless vandalism, an alarming demonstration of American willingness to use nuclear weapons and to despoil the heavens. The moon held a place in human imagination and culture across every society on Earth, a symbol of beauty and constancy and wonder. To mark it with a nuclear explosion might strike people around the world not as impressive, but as horrifying, a violation of something precious and shared. The propaganda value that the planners assumed might prove illusory, or might even reverse, turning the intended demonstration of strength into a demonstration of recklessness that damaged American standing rather than enhancing it. These considerations, accumulating as the study deepened, began to undermine the case for the project from within. The science that had been commissioned to determine how to carry out the detonation was, in the process, revealing all the reasons why the detonation should not be carried out. The feasibility was real, but so were the costs and the risks. And as the scientists worked through the implications, the wisdom of the entire undertaking came increasingly into question. The study had been meant to determine how to bomb the moon. It was, instead, building the case for leaving the moon alone, one of the most remarkable aspects of the lunar nuclear detonation story, and one that did not become clear until decades later when the records of both superpowers were opened, is that the United States was not alone in considering this extraordinary idea. On the other side of the Cold War, in the secret design bureaus of the Soviet Union, scientists and engineers were contemplating the very same thing. The Soviet Union, like the United States, had conceived a plan to detonate a nuclear weapon on the moon for very much the same reasons, and had pursued it in parallel, each superpower entirely unaware that its rival was independently considering the identical act. The Soviet project emerged from the same source as the American one: the dynamics of the space race and the desire for a dramatic demonstration of national capability. The Soviet Union, having achieved the triumph of Sputnik, was eager to maintain its lead and to produce further spectacular firsts that would demonstrate the superiority of the Soviet system. The Soviet space program, under the direction of the brilliant chief designer Sergei Korolev, was pursuing an ambitious series of lunar missions, attempting to be the first to reach the moon with probes, to photograph it, to impact it. Within this program, the idea arose of detonating a nuclear weapon on the lunar surface, producing a flash that would be visible from the Earth and that would demonstrate, unmistakably, that the Soviet Union had reached the moon and could mark it with the power of the atom. The Soviet plan was part of a series of proposed lunar missions designated by the letter E, and the nuclear detonation concept fell within this series. The proposal envisioned sending a nuclear device to the moon aboard one of the Soviet lunar probes and detonating it on the surface, achieving the same visible demonstration that the Americans were independently studying. The Soviet planners faced the same fundamental challenge that confronted the Americans, the challenge of producing an explosion that would actually be visible from the Earth, set against the darkness of the unlit portion of the moon, bright enough to be seen across the vast distance. And they confronted the same questions about delivery, about the reliability of the rockets, and about the consequences of failure. The parallel between the two programs is striking and, in a sense, deeply revealing about the logic of the Cold War. Two rival superpowers, separated by ideology and locked in a dangerous confrontation, each operating in total secrecy and entirely unaware of the other's deliberations, independently arrived at the same extraordinary idea. This convergence was not a coincidence. It was the product of the shared logic of the competition. Both superpowers were driven by the same desire to demonstrate supremacy through spectacular achievement. Both possessed nuclear weapons and were developing the rocketry to reach the moon. Both understood the propaganda value of a visible demonstration of power. Given these shared conditions, it is perhaps not surprising that both arrived at the same conclusion, that a nuclear detonation on the moon would be the ultimate demonstration. The idea was, in a grim sense, the logical endpoint of the space race's competitive dynamic, the place where the desire for spectacle and the possession of nuclear weapons and the capability to reach the moon all converged. The Soviet plan, like the American one, was ultimately abandoned, and for largely the same reasons. The Soviet planners recognized the grave risk of failure, the danger that a rocket carrying a nuclear weapon might fail and bring its deadly cargo back down, potentially onto Soviet territory. The reliability of the rockets was insufficient to make the risk acceptable. The Soviet planners also confronted the technical difficulty of ensuring that the explosion would actually be visible from the Earth, the same uncertainty that had troubled the American study. And there were doubts about whether the demonstration would achieve its propaganda purpose, or would instead provoke alarm and condemnation. For these reasons, the Soviet Union, like the United States, drew back from the plan, deciding that the risks and costs outweighed the potential benefits. The Soviet project to bomb the moon, like its American counterpart, was quietly shelved, its existence concealed for decades. The fact that both superpowers conceived, studied, and then abandoned the same plan offers a measure of reassurance amid the alarm that the story naturally provokes. It would be easy to view the American plan in isolation as evidence of a peculiarly American recklessness, a unique willingness to despoil the heavens for propaganda. But the parallel Soviet plan demonstrates that the impulse was not uniquely American. It was a product of the Cold War itself, of the competitive logic that gripped both superpowers, and both, in the end, proved capable of recognizing the folly and pulling back. The reassurance lies not in the conception of the plans, which reflects the dangerous extremes to which the Cold War pushed both sides, but in the abandonment of them, which reflects a shared capacity for restraint and judgment that operated, fortunately, on both sides of the Iron Curtain. There is a further irony in the parallel. Korolev, the Soviet chief designer whose program included the lunar nuclear proposal, would go on to lead the Soviet effort to send cosmonauts to the moon, the same moon his program had once proposed to bomb. And the United States, having abandoned its plan to detonate a weapon on the moon, would go on, a decade later, to land human beings on it. Both superpowers, having contemplated marking the moon with nuclear fire, instead chose to reach it with rockets, and, in the American case, with human explorers. The trajectory of both programs, from the conception of the bombing to its abandonment and the eventual pursuit of exploration, traced the same arc. The arc from the destructive logic of the early Cold War toward something more constructive and more worthy of the human reach toward the heavens. To understand how close the United States came to actually carrying out the lunar nuclear detonation, it is necessary to set aside the perspective of the present and to inhabit, as fully as possible, the perspective of 1958. From the vantage point of today, the idea of bombing the moon appears self-evidently absurd, a plan so obviously reckless and pointless that one struggles to understand how serious people could have considered it. But the people who considered it were serious, intelligent, and responsible. And they considered it because, in the specific circumstances of 1958, it appeared to many of them to be a rational response to a genuine crisis. Understanding why they almost did it requires understanding why, at that moment, it seemed like it might be a good idea. The crisis was real, and it was acute. The United States had been humiliated by Sputnik and by the failure of its own initial response. The American public was frightened and demoralized. American allies around the world were questioning whether the United States remained the technological and military leader of the free world, or whether the Soviet Union had seized that position. The Soviet Union was exploiting its space achievements relentlessly for propaganda, presenting them as proof of the superiority of the communist system. American leaders faced enormous pressure to reverse this narrative, to demonstrate that the United States remained supreme, and to do so quickly and dramatically. In this atmosphere, the normal constraints on policy thinking were loosened, and ideas that would ordinarily have been rejected received serious consideration. The lunar nuclear detonation, viewed through the lens of this crisis, offered a solution that addressed the problem directly. The fundamental issue was one of perception, of demonstrating American supremacy in a way that the entire world would witness and understand. A nuclear explosion on the moon, visible from the Earth, would accomplish exactly this. It would be the most dramatic demonstration of technological and military power imaginable, far more impressive than any satellite. It would show that the United States could reach the moon, that it possessed nuclear weapons of immense power, and that it could combine these capabilities to produce an effect visible across the entire planet. In a single stroke, it would erase the impression of American inferiority that Sputnik had created, and replace it with an overwhelming demonstration of American capability. For leaders desperate to reverse the post-Sputnik narrative, the appeal of such a demonstration was genuine. The military dimension reinforced the appeal. The demonstration would not merely impress, it would also intimidate. By showing that American nuclear weapons could reach the moon, the United States would implicitly demonstrate that they could reach any target on the Earth. This was a message of particular value in the context of the missile gap fears, when the United States wished to convince both the Soviet Union and the world that American nuclear forces were formidable and that American weapons could strike anywhere. The lunar detonation would be, among other things, a demonstration of strategic reach, a way of telling the Soviet Union that it could not hide from American nuclear power anywhere, not even on the moon. For military planners concerned with deterrence and with projecting strength, this aspect of the proposal had real value. There were, moreover, voices within the American military and scientific establishment who supported the project, who believed that the benefits justified the risks, and that the United States should proceed. The project would not have advanced to a serious classified study, would not have been funded and staffed and pursued for the better part of 2 years, if it had been universally regarded as absurd. It advanced because significant people took it seriously, because they believed that the demonstration of power it offered was worth the considerable difficulties and risks involved. The study was not a fringe undertaking, dismissed by everyone responsible. It was a genuine examination of a proposal that genuine decision-makers were genuinely considering, and the fact that it received such examination is itself a measure of how close the United States came to attempting it. The closeness should not be overstated, however, and it is important to be accurate about how far the project actually advanced. The study established the feasibility of the project and examined its implications, but it remained a study, a feasibility assessment, rather than an operational program with a launch date and an assembled weapon. The United States did not reach the point of actually preparing a weapon for launch to the moon. The project did not progress to the stage of imminent execution. What the United States did was to take the idea seriously enough to study it rigorously, to assemble a team, to fund the work, and to consider whether to proceed. That is closer than one might wish, closer than the absurdity of the idea would suggest, but it is not the same as having a nuclear weapon on a launch pad pointed at the moon. The plan was studied, considered, and ultimately rejected, and the rejection came before the project advanced to operational preparation. Still, the fact that it advanced as far as it did, that the United States seriously studied detonating a nuclear weapon on the moon, that some responsible people supported the idea, that it was pursued for the better part of 2 years, is sobering. It demonstrates how the fear and competitive pressure of the early Cold War could push even a responsible government toward extraordinary extremes, could make the unthinkable thinkable, could lead serious people to study seriously a plan to mark the moon with nuclear fire for the sake of a propaganda gesture. The lunar nuclear detonation was not the product of a single madman or a fringe faction. It was the product of a national crisis and the pressure it generated. And that is precisely why it is so revealing. It shows what fear can do to judgment, even the judgment of capable and responsible people. And it raises the question that the next chapter of the story answers. What in the end allowed wisdom to prevail over fear and led the United States to choose not to do it? The decision to abandon the lunar nuclear detonation came in 1959. And it represented the triumph of judgment over the fear and competitive pressure that had given rise to the project. The reasons for the cancellation were several, and together they amounted to a recognition that the costs and risks of the undertaking far outweighed whatever benefits it might produce. The study that had been commissioned to determine how to bomb the moon had, in the course of its work, assembled a compelling case for why bombing the moon was a mistake. And that case ultimately prevailed. The first and most immediate reason concerned the risk of catastrophic failure. The rockets of 1959 were unreliable as the repeated and public failures of American test launches had demonstrated. To launch a nuclear weapon toward the moon aboard such a rocket was to accept a real probability that the rocket would fail, and a rocket failure with a nuclear weapon aboard carried consequences too terrible to accept. A weapon might fall back to the Earth, potentially detonating or scattering radioactive material over populated areas, including American or Allied territory. The prospect of a nuclear weapon coming down on an American city because of a rocket malfunction was a nightmare that no responsible planner could dismiss, and the unreliability of the available rockets made it a genuine possibility rather than a remote one. The risk of failure, with its catastrophic potential consequences, weighed heavily against proceeding. The second reason was the scientific cost. As the study had revealed, a nuclear detonation on the moon would contaminate the lunar surface with radioactive material, compromising the scientific value of the moon for generations. The moon was a pristine natural laboratory, preserving a record of the solar system's history that scientists wished to study. To scatter radioactive debris across its surface would be to vandalize this treasure, to damage forever the ability of future scientists to study the moon in its natural state. As the scientific importance of the moon became clearer, and as the prospect of actual lunar exploration grew more real, the folly of contaminating the moon for the sake of a propaganda flash became increasingly apparent. The United States was, even then, beginning to contemplate sending probes and eventually humans to the moon, and a contaminated moon would complicate or compromise these future endeavors. The third reason, and perhaps the most important, was the recognition that the propaganda value of the detonation was uncertain and might even be negative. The entire project rested on the assumption that a nuclear explosion on the moon would impress the world and intimidate the Soviet Union, enhancing American prestige. But this assumption was questionable. It was at least as likely that the world would react with horror rather than admiration, that the spectacle of the United States detonating a nuclear weapon on the moon would be seen as an act of reckless vandalism, an alarming demonstration of American willingness to use nuclear weapons and to despoil the heavens. The moon held a cherished place in human culture and imagination across every society on Earth. To mark it with nuclear fire might strike people not as a triumph of American power, but as a violation of something beautiful and shared, a frightening rather than reassuring display. The planners came to recognize that the demonstration might damage American standing rather than enhance it, that it might confirm fears about American recklessness rather than dispel doubts about American strength. There was also, underlying these specific considerations, a broader recognition that a destructive gesture was the wrong response to the challenge the United States faced. The problem the United States confronted after Sputnik was a problem of demonstrating that the American system was superior, that it represented a better path for humanity than the Soviet alternative. A nuclear explosion on the moon would demonstrate American power, but it would not demonstrate American superiority in the deeper sense, the sense that mattered for the long competition with the Soviet Union. It would show that the United States could destroy, but the contest was ultimately about which system could build, could create, could offer humanity a better future. The right response to Sputnik was not to bomb the moon, but to surpass the Soviet achievement through superior accomplishment, to reach the moon constructively rather than to mark it destructively. This recognition that the destructive gesture was beneath the United States and would not serve its true interests contributed to the decision to abandon the plan. Leonard Reiffel, who had directed the study, would later recall that he had argued against proceeding, that he had warned of the costs and risks, and that he had been relieved when the project was canceled. The decision to abandon the plan was made by those with the authority to make it, on the basis of the considerations the study had brought to light, and it represented a victory for the kind of careful judgment that the panic of 1958 had threatened to override. The United States had considered an extraordinary and reckless act, had studied it seriously, and had then drawn back, choosing not to do it. The moon would remain unmarked by nuclear fire. The wisdom to refrain had prevailed over the fear that had tempted. The cancellation was conducted as quietly as the study itself had been. The project was simply discontinued, its records classified, its existence concealed. There was no public announcement because there had been no public knowledge of the project to begin with. The United States had secretly considered bombing the moon and had secretly decided not to, and the entire episode disappeared into the classified archives, where it would remain hidden for decades. The public knew nothing of how close the United States had come to detonating a nuclear weapon on the moon, nothing of the study, nothing of the decision to abandon it. The story would not emerge until the year 2000, when Leonard Reiffel, by then an old man, would reveal it to the world, and the secret plan of 1958 would finally become known. The most profound aspect of the lunar nuclear detonation story is not the plan itself, but what came after it. The trajectory that the United States followed in the years following the decision to abandon the bombing. For in those years, the United States traveled from one conception of how to engage the moon to its opposite, from the idea of marking the moon with nuclear fire to the achievement of landing human beings gently upon it. The same nation that had considered, in 1958, detonating a weapon on the lunar surface would, 11 years later, place 2 men upon that surface, plant a flag, gather rocks, and bring its explorers safely home. The transformation from the one conception to the other is the deepest meaning of the story, the measure of how far the United States traveled from the panic of 1958 to the triumph of 1969. The shift began with a change in how the United States understood the challenge it faced. In 1958, in the immediate aftermath of Sputnik, the challenge was understood as a problem of demonstrating power, of producing a dramatic gesture that would impress and intimidate. The lunar nuclear detonation was a product of this understanding, a gesture of pure demonstration, spectacular and destructive. But as the United States recovered from the initial shock of Sputnik and developed a more considered response, the understanding of the challenge evolved. The competition with the Soviet Union came to be understood not merely as a contest of dramatic gestures, but as a contest of genuine accomplishment, of which system could actually achieve more, build more, reach further through constructive effort. This evolution in understanding pointed away from the destructive gesture and toward constructive achievement. The decisive articulation of this new understanding came from President Kennedy in 1961, when he committed the United States to landing a man on the moon and returning him safely to the Earth. Kennedy's commitment represented a conception of how to engage the moon that was the precise opposite of the 1958 plan. Where the earlier plan had proposed to detonate a weapon on the moon, demonstrating power through destruction, Kennedy's commitment proposed to land human beings on the moon, demonstrating capability through constructive achievement. Where the earlier plan had sought to mark the moon with nuclear fire, Kennedy's vision sought to reach it with human explorers. The contrast could not be sharper. The same destination, the moon, was approached in 2 entirely different spirits, the spirit of destruction and the spirit of exploration, and the United States chose the latter. The choice reflected a recognition that exploration, not destruction, was the path to genuine victory in the competition with the Soviet Union. To land human beings on the moon and return them safely would demonstrate American capability far more impressively and far more constructively than any explosion. It would show that the United States could accomplish the most difficult feat in the history of human endeavor, could organize the enormous effort required, could develop the technology, could risk and protect human lives, and could succeed. And it would do so in a way that inspired rather than alarmed, that drew the admiration of the world rather than its horror. that demonstrated the constructive power of the American system, rather than merely its destructive capacity. The lunar landing would be a demonstration of superiority in the deepest sense, the sense that mattered for the long competition. And it would be achieved without despoiling the moon or scattering radioactive contamination across its surface. The achievement of the lunar landing in 1969 completed the transformation. When Neil Armstrong and Buzz Aldrin landed on the moon and walked upon its surface, they did so in the spirit of exploration that had replaced the spirit of destruction. They did not detonate a weapon. They gathered samples, deployed scientific instruments, and took photographs. They left behind not radioactive contamination, but a plaque bearing words of peace, declaring that they had come in peace for all mankind. The moon that the United States had once considered bombing was instead explored, studied, and treated with the reverence due to a natural wonder and a scientific treasure. The footprints that Armstrong and Aldrin left in the lunar soil were the antithesis of the nuclear crater that the 1958 plan had contemplated, the gentle mark of human exploration rather than the violent mark of human weaponry. The Soviet trajectory followed a parallel arc. Sergei Korolev, whose program had included the proposal to detonate a nuclear weapon on the moon, went on to lead the Soviet effort to send cosmonauts to the moon, the same constructive ambition that animated the American program. The Soviet lunar landing effort ultimately failed, defeated by the failure of the N-1 rocket and the loss of Korolev himself. But the ambition had shifted, on the Soviet side as on the American, from the destructive conception to the exploratory one. Both superpowers, having contemplated marking the moon with nuclear fire, turned instead to the dream of reaching it with human explorers. The arc from bombing to landing was traced, in intention if not in full achievement, on both sides of the Cold War. The transformation from the 1958 plan to the 1969 achievement is, in the end, a story of growth, of a nation moving from a panicked and destructive first impulse toward a considered and constructive accomplishment. The panic of 1958 had produced the idea of bombing the moon. The maturity of the 1960s produced the achievement of landing on it. The United States had grown, in those 11 years, from a frightened nation casting about for a dramatic gesture into a confident nation capable of the most constructive achievement in human history. The moon, which might have borne the scar of a nuclear explosion, bore instead the footprints of human explorers. And that difference, between the scar and the footprints, between destruction and exploration, between the panic of 1958 and the triumph of 1969, measures the distance that wisdom traveled in those years, and the value of the decision, made quietly in 1959, to leave the moon unmarked by nuclear fire. The deepest lesson of the lunar nuclear detonation story is a lesson about the nature of true strength, and it runs counter to the assumption that gave rise to the plan in the first place. The plan was conceived on the premise that strength is demonstrated through the exercise of power, that the way to prove American supremacy was to do something dramatic and destructive, to show what American weapons could accomplish. But the abandonment of the plan rested on a deeper understanding, the understanding that true strength is demonstrated not merely through the capacity to act, but through the wisdom to choose how and whether to act. The greatest demonstration of American strength in the end was not the detonation that was contemplated, but the restraint that was exercised. The United States proved its maturity not by bombing the moon, but by choosing not to. This is a difficult truth to grasp, because it asks us to find significance in something that did not happen, to see an achievement in an act of restraint. The bombing of the moon would have been visible, dramatic, unmistakable. The decision not to bomb the moon was invisible, undramatic, concealed for decades. Yet the decision not to act was the wiser and, in the deepest sense, the stronger choice. It reflected a capacity for judgment that the dramatic gesture would have lacked, an ability to weigh consequences, to recognize costs, to see beyond the immediate temptation of the spectacular demonstration toward the longer-term interests and values at stake. The strength that matters most is not the strength to destroy, but the strength to refrain from destruction when destruction would be wrong. And that strength is harder to see and harder to celebrate precisely because it manifests in the absence of action rather than its presence. The moon itself stands as the monument to this wisdom, though it bears no marker and no inscription to commemorate the decision. The moon that we see in the night sky, unmarked by any nuclear crater, undisturbed by any radioactive contamination, is the physical evidence of the choice that both superpowers made to leave it alone. Every person who has ever looked up at the moon since 1959, every poet who has written of it, every lover who has gazed at it, every child who has wondered at it, has looked at a moon preserved by the decision not to bomb it. The intact moon is a kind of monument, invisible in its significance, to the wisdom that prevailed over the fear and the competitive pressure of the early Cold War. We do not notice it because we cannot see what was prevented, but the unmarked moon is the result of a choice, and the choice was the right one. There is a particular significance in the fact that both superpowers, independently, made the same wise choice. It would be troubling if only one side had shown the judgment to refrain, for it would suggest that the restraint was a matter of national character rather than of broader human wisdom. But both the United States and the Soviet Union, each operating in secret, each driven by the same competitive pressures, each possessing the means to bomb the moon, arrived at the same decision to refrain. This convergence offers a measure of reassurance about the human capacity for judgment, even amid the dangers of the Cold War. The same competitive logic that had pushed both sides toward the destructive idea also contained, on both sides, the capacity to recognize the folly and to pull back. The wisdom was not the property of one nation, but a shared human capacity, operating on both sides of the Iron Curtain, and the moon was preserved by the exercise of that capacity by both rivals. The story also illuminates the relationship between fear and judgment, a relationship of permanent relevance. The plan to bomb the moon was a product of fear, the fear that gripped the United States after Sputnik, the fear of falling behind, of appearing weak, of losing the competition with the Soviet Union. Fear is a powerful force, and it can drive even capable and responsible people toward extreme and destructive actions, can make the unthinkable seem reasonable, can override the judgment that calmer circumstances would preserve. The lunar nuclear detonation was nearly a casualty of fear, an act that fear nearly drove the United States to commit. That it was not committed, that judgment ultimately prevailed over fear, is the heartening conclusion of the story, but the fact that it came as close as it did is a permanent warning about the power of fear to distort judgment, a warning that applies far beyond the specific circumstances of 1958. The greatest acts in this story, then, were not the dramatic ones. They were not Sputnik, nor the rockets, nor even, in a sense, the eventual lunar landing. The greatest act was the quiet decision, made in 1959 and concealed for decades, to refrain from a reckless and destructive gesture, to choose judgment over fear, to leave the moon unmarked. This act produced no flash visible from the Earth, generated no headlines, won no propaganda victory. It was invisible, and it remained secret, and it has never received the recognition that the dramatic achievements of the space race have received. But it was, perhaps, the wisest thing that either superpower did in the entire competition, and the intact moon that hangs in our sky is its lasting and unremarked memorial. In an age that often measures strength by the capacity to destroy, the story of the moon that was not bombed offers a different measure, the measure of strength as the wisdom to refrain. The United States and the Soviet Union each demonstrated this strength when they chose, in secret, not to mark the moon with nuclear fire. It was a demonstration that no one saw, that won no acclaim, that remained hidden for 40 years. But it was real, and it was important, and it preserved for all of us the unmarked moon that our ancestors knew and that our descendants will know. The moon that two superpowers, in a moment of fear, considered bombing, and that wisdom, in the end, preserved. The factual record of the lunar nuclear detonation plan, assembled from the disclosures that began in the year 2000 and from the documents that have since become available, allows the story to be told with precision, and the precision makes it no less remarkable. The plan was real, it was studied seriously, and the details that have emerged confirm both its earnest pursuit and its ultimate, fortunate abandonment. The project was initiated in 1958, in the immediate aftermath of the Sputnik shock of October 1957. It was conducted under the authority of the United States Air Force, which carried much of the responsibility for the American missile and space effort in this period. The scientific work was contracted to the Armor Research Foundation, a research institution affiliated with the Illinois Institute of Technology in Chicago. The project carried the official, deliberately bland designation, a study of lunar research flights, and within the circle of those cleared to know of it, it was identified as Project A119. The name was chosen, like the cover names of many classified programs, to reveal nothing of the project's true and alarming purpose. The study was directed by the physicist Leonard Reiffel, an accomplished scientist who would later hold senior positions at NASA and pursue a distinguished career. Reiffel assembled a team of about 10 scientists to conduct the study. Among them was the young Carl Sagan, then in his early 20s, who would go on to become the most celebrated science communicator of his generation. Sagan's contribution concerned the modeling of the dust cloud that the explosion would produce and its visibility from the Earth, work that connected to genuine scientific questions about the lunar environment. The involvement of Sagan, later inadvertently disclosed in a fellowship application and discovered by a biographer decades afterward, is among the most striking details of the entire story. The weapon contemplated for the detonation evolved as the study confronted the practical constraints of delivery. The limited lifting capacity of the rockets available in the late 1950s constrained the mass that could be sent to the moon, and this constraint pushed the planners toward a relatively small nuclear device rather than the massive thermonuclear weapons of the era. The study is understood to have considered a warhead in the range of the smaller weapons in the American arsenal, a device powerful enough to produce a visible flash, but light enough to be delivered with the available rocketry. The detonation was to occur near the terminator of the moon, the line dividing the sunlit and dark portions of the lunar surface, where the flash would stand out against the darkness and be most visible from the Earth. The Soviet parallel, which became known through the opening of Soviet records, confirmed that the United States had not been alone in considering the idea. The Soviet Union had developed its own proposal to detonate a nuclear weapon on the moon, part of a series of lunar mission concepts designated by the letter E and pursued within the program directed by Sergei Korolev. The Soviet plan, like the American one, aimed at a visible demonstration of capability, and like the American one, it was ultimately abandoned for reasons of risk and feasibility. The independent convergence of the two superpowers on the same extraordinary idea and their independent abandonment of it is one of the most revealing facts of the entire episode. The reasons for the American cancellation in 1959 were several and reinforcing. The risk of catastrophic failure, the possibility that an unreliable rocket might bring a nuclear weapon back down onto the Earth, weighed heavily. The scientific cost, the contamination of the pristine lunar surface with radioactive material, became increasingly apparent as the scientific value of the moon was better appreciated. And the uncertainty of the propaganda benefit, the real possibility that the world would react with horror rather than admiration, undermined the central rationale for the project. Together, these considerations led to the decision to abandon the plan, a decision made quietly and concealed for decades. The secrecy surrounding the project lasted for more than 40 years. The study was conducted in secret, the decision to abandon it was made in secret, and the entire episode disappeared into the classified archives, unknown to the public. It was not until the year 2000 that Leonard Reiffel, by then an elderly man, revealed the existence of the project to the public, disclosing that the United States had seriously studied detonating a nuclear weapon on the moon in the late 1950s. Reiffel's disclosure brought the story into public knowledge for the first time, more than 4 decades after the events, and it was through his account that the world learned how close the moon had come to bearing the mark of a nuclear explosion. The final comparison that the numbers invite is the comparison between what was contemplated and what actually occurred. The plan of 1958 contemplated a nuclear crater on the moon, a flash of atomic light visible from the Earth, radioactive contamination scattered across the lunar surface. What actually occurred, 11 years later, was the gentle landing of Apollo 11. 2 sets of human footprints in the lunar soil, a plaque declaring that the visitors had come in peace for all mankind, and the careful gathering of lunar samples for scientific study. The contrast between the contemplated crater and the actual footprints measures the distance between the 2 conceptions of how to engage the moon, the destructive and the exploratory, and it stands as the final statistic of the story. The moon bears the footprints of explorers, not the crater of a bomb, and the difference is the measure of the wisdom that prevailed. The plan to bomb the moon, studied seriously in 1958, abandoned wisely in 1959, concealed for 40 years, and revealed at last in 2000, remains one of the most extraordinary episodes of the space race, a glimpse of how close fear came to driving the superpowers to mark the moon with nuclear fire, and a testament to the judgment that, on both sides, ultimately chose to leave it alone. More than 60 years have passed since a small team of scientists in Chicago studied, in secret, whether the United States should detonate a nuclear weapon on the moon. The plan was abandoned, concealed for 4 decades, and finally revealed to a world that had never suspected how close it had come to seeing the moon marked by atomic fire. Today the story is known, documented, and confirmed, and it takes its place among the strangest and most sobering episodes of the Cold War. But its deepest meaning lies not in the alarm it provokes at how close the superpowers came, but in the reassurance it offers about the wisdom that, in the end, prevailed. The story is, above all, a window into the power of fear to distort judgment, and into the capacity of judgment, ultimately, to reassert itself. The plan to bomb the moon was born of fear, the fear that gripped the United States after Sputnik, the fear of weakness and humiliation and defeat. That fear was powerful enough to make a reckless and destructive idea seem reasonable, powerful enough to drive serious people to study seriously a plan that, in calmer times, they would have dismissed without a second thought. The fear nearly prevailed, but it did not. In the end, judgment reasserted itself. The costs and risks were weighed, the folly was recognized, and the plan was abandoned. The story is a reminder that fear can drive even responsible nations toward extraordinary extremes, and also a reminder that the capacity for wisdom, though it may be nearly overwhelmed by fear, can survive and prevail. There is no more fitting symbol of this story than the figure of Carl Sagan, the young scientist who calculated how the dust cloud of a lunar nuclear explosion would behave, and who grew into the man who taught the world to love the cosmos. The young Sagan, swept up in the fear and the competitive urgency of 1958, lent his brilliant mind to the study of how to bomb the moon. The mature Sagan became the most eloquent voice of his age for the peaceful exploration of space, for the wonder and beauty of the heavens, for the preciousness of the Earth and its place in the cosmos. He became a leading opponent of nuclear weapons, a man who warned of the catastrophe of nuclear war, and who pleaded with humanity to step back from the brink. The arc of Sagan's life, from the young man who studied bombing the moon to the mature man who celebrated it, traces the same arc that the United States itself traveled, from the panic that conceived the bombing to the wisdom that rejected it, and the maturity that chose exploration instead. In Sagan, the story finds its human embodiment, the brilliant mind that grew, as his nation grew, from fear toward wisdom. Leonard Reiffel, who directed the study and who revealed it to the world in 2000, reflected in his later years on the project he had led, and his reflections carried the weight of a man who had glimpsed a path not taken. He expressed relief that the plan had been abandoned, recognizing in his maturity the folly of what had been contemplated. He understood that to have detonated a nuclear weapon on the moon would have been an act of vandalism against a natural wonder, a reckless gesture that might have damaged American standing rather than enhancing it, and a desecration of an object that belonged, in a sense, to all of humanity. Reiffel had done his work, had led the study with the rigor the Air Force demanded, and had then been glad, in the end, that the work led to a decision not to proceed. His relief, expressed decades later, was the relief of a man who had helped to study a mistake and had been spared the consequences of committing it. The moon hangs in our sky tonight, as it is hung in the sky of every human generation, unmarked by any nuclear crater, undisturbed by any radioactive contamination, the same moon that our ancestors knew and that our descendants will know. We look at it without knowing that two superpowers once considered marking it with atomic fire, without knowing how close it came to bearing a scar that would have lasted for the rest of human history. The intact moon is a gift, though we do not recognize it as such, the gift of the wisdom that chose, on both sides of the Cold War, to leave it alone. The next time you look up at the moon, consider that it might have been otherwise, that in a moment of fear, two nations contemplated bombing it, and that the cleanest and most beautiful object in our night sky was preserved by the decision, made in secret and concealed for decades, not to do it. The moon we were given, the unmarked moon, is the monument to that decision, and it is a monument worth contemplating. In the end, the story of the plan to bomb the moon is a story about the difference between what we can do and what we should do, between the capacity for action and the wisdom to refrain. Two superpowers, at the height of their fear and their rivalry, possessed the capacity to mark the moon with nuclear fire. Both chose not to. That choice, invisible and unacclaimed, was among the wisest things either of them did, and its result hangs in our sky every night, a pale and constant reminder that the greatest strength is sometimes the strength to refrain, and that the moon we love was preserved, in a moment we never knew about, by the triumph of wisdom over fear. If this account of the secret plan to bomb the moon revealed a side of the space race you had never imagined, consider subscribing to Space Race Tales. Every week, we bring you the untold stories of the Cold War cosmos, the secret programs and hidden plans, the cosmonauts and astronauts who flew impossible missions, and the secrets that two superpowers spent decades concealing from the world. The space race held more secrets than anyone imagined, and we are only beginning to uncover them. Subscribe, hit the notification bell, and join us for the next chapter.